Hey folks, we're going to talk about 13.3 dot plots. Let's cover a little bit more. Remember that a dot plot or a line plot is a frequency chart that displays it's a frequency chart that is displayed on a number line. Observations, the number of observations is the number of pieces of data collected in the sample. The spread of the data is the range of the data points. Attributes. An attribute is a specific characteristic or feature of the graph. In other words, it is what the graph is about. So steps to creating a dot plot. First, determine the highest and lowest values. Next, create a number line. And third, place a dot or an X above every number for each occurrence of that number in the data set. Note, the numbers in the number line and the dots must be equally spaced apart. Must be equally spaced in order to accurately reflect the data. It is important that you do not skip segments of numbers on the number line as well. If you do that, then you're just simply missing data. You don't want to do that. If you look at the pictures below, you can see that the data has different shapes. Notice how this one makes a curve, and this one kind of makes a downward slide. The one on the left here, the skewed bell-shaped distribution, it's also called a normal distribution. If more than 30 people are sampled, the distribution is almost always normal. And this means that most of the data falls in the center and then fewer data points on both sides. A skewed right or positive distribution, most of the data falls towards the extreme. The plot looks like it has a tail to the right. Notice how the majority of your data is over here, but then as you go down or go out, it starts to drop in the number of events. Skewed left or negative distribution, most of the data falls towards the upper extreme, and the plot looks like it has a tail to the left. If you notice here, the majority of your data is over here on the high side, and its drop is down here toward the lower numbers or toward the negative side. You also have a uniform distribution, and this indicates that there were similar or exact data points for each data set collected in the sample. Do you notice anything about this graph here? Look at the data. Do you notice anything? Try to think of mean, median, and mode. If you notice, here and here, 25 and 40 are both modes. This means it is also called bimodal, meaning it has two modes. So let's look at the example on the left. How many total students are there in all of the classes? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, and 30. 30. Now, which class has the least number of students? Daisy, right? Which class has the most number of students? Evan. If you notice, line plots or dot plots help to provide a good visual representation to quickly pull out data or attributes of the data. Now let's look over here at the lemons. How many total individuals are represented in the dot plot? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. I missed one. So you got 28. What is the total number of lemons that the individuals have? What is the total number of lemons that the individuals have? Well, here what you got to do is this. You have 4 that have 11, 3 that have 12, 1, 2, 3, 4, 5, 6, 6 for 13, 1 for 14, 1, 2, 3, 4, 5, 6, 6 for 15, 5 for 16, 1, 2, 3, 3 for 17. So, for instance, 4 people had 11. So that means there are 44 lemons here. 3 people had 12 lemons, so that is 36. 6 people had 13. 6 times 13 is 78. Then 14, because only one person had that. Now you have 6, 15. 6 times 15 is 90. 5 had 16. That's 80. And lastly, 3 had 17. And that gives you 51. Now we have to add all of this up. 44 plus 36 plus 78 plus 14 plus 90 plus 80 plus 51. That's going to give us 393 total lemons. Okay? Okay. I hope this helped you guys out. Take a look back at the notes if you need to. Move on to the exit slip and give it a try. If you run into problems, let us know. We'll be in contact if need be. And